The ZCL vector class has gotten a new version, Alpha 2, with some important changes. Firstly, we encapsulated the constructor behind a static method called createInstance, which takes most of the previous parameters but now has a capability to generate random values itself in addition to receiving a pre-constructed axis via parameter x. It also now has the ability to preset the rank of the vector when initial vectors are created. Of importance is the automation of type creation based on the value of ABAP kind, and the creation of a dynamic table for that type. It is then either returned with initial values, or filled in with random element. As mentioned in the introduction of this video, createInstance is now a static method to avoid the exposure to the constructor. Parameters x of type axis and v of type reference to an existing vector instance are optional and initialize the new instance with a vector whose components are provided by the axis x, or by the instance v of a vector. We added a deep boolean defaulted to false, thus creating a shallow copy of v into the new instance. If this boolean is true, a deep copy is created using the contents of v's axis. Recall that our test function module provided the axis for each vector from random variables of the same type. To further encapsulate patterns, we added a boolean named rand to tell ZCL vector that its instance should be initialized with random variables should this boolean be true. At last, to support the creation of randomized or empty vectors, we provided the rank variable which defines the dimensions the vector operates on. We checked if the kind asked for either shallow or deep copy is the same as the one of the source vector and tested for deep copies. We efficiently execute a deep copy by means of the table copy operator. If neither x nor v are provided, we create the underlying type from the utilities library, and proceed to create a dynamic table to which either zeros or random elements are returned. A test for integer is performed, and the selection of the correct rando element is chosen. Although possible, and present in languages like Julia, we would not implement vectors of non-numeric types for this project, leaving it for inheritance. For that, we should remove the final indicator for class ZCL vector. Next video introduces two classes, ZCL matrix and ZCL eigencomposition, which are necessary for the cross-operator method of vectors. Until then, click the like button if you enjoy this video.